All right, the title of today's notes is Solving for Theta, Part 1. Okay, we're going to do Part 2 on Friday. Part 1 today. So solving is working backwards. So what we've been doing all this time, we're now we're gonna be working backwards. I'm not gonna give you the angle. We're gonna have to find the angle. I'll give you the answer and that kind of thing. So uh, there's a few more steps involved, and we want to be careful to do it right today and get down what we're doing today, so that when we get to Friday, it's going to get more complicated on Friday. That it's going to go smoothly for us on Friday. So what I'm showing you today are more the basics, the foundation. It won't feel basic, but are the basics. Okay. So let's take a look at an example here. So find theta for theta between 0 and 360 degrees. And I tell you that the sine of theta is 1/2. Okay. And so we want to find an angle that would make this work. And not only an angle, but we want to find every angle between 0 and 360 that would make this work. So there's more than one solution. We want to find them all. And I'm going to restrict you between 0 and 360, because if I don't do that, then there's actually an infinite number of possibilities. They're all the coterminal angles. So by doing this, by restricting it between 0 and 360, I'm saying, what's everything that's not coterminal with each other, right? So just different locations on that unit circle that we're after. So to do this, you're going to want to follow a certain order of thinking here. The first piece, or the first question you want to ask, is what's my reference angle? Or do I even have a reference angle? Maybe it's on the x-axis, maybe it's on the y-axis. But that's the first thing you want to go after. And the answer to that question is either going to be 30, 45, or 60 if you have a reference angle. If it's not, then it's going to, we're going to be working with the x-axis or the y-axis. And so to answer this question, sometimes it's nice to draw just a right triangle with a hypotenuse of 1. And because when you do that, you know, okay, the sine is the side opposite. There's where the 1/2 goes. And then the question is, do I know what theta prime is there? Is this, because we've memorized these triangles, do I recognize this triangle now? And hopefully you do. And so what is theta prime? Okay, so we found our reference angle. Then the second question is, which quadrants could we be working in? So question number 2. Assuming we're in a quadrant, which ones would we be working in? And to answer this, we're going to look at the sign of, well, not the sign, but the sign of the number. So in other words, here we're looking at a positive 1/2, not a negative 1/2. Because the quadrants, all they do is change, is it going to be negative or positive, right? That besides the reference angle, that's kind of the function of those different quadrants. So in which quadrants can the sign of a number be positive? That's what we're after. So if I draw my reference triangle in quadrant 1 and put a 30-degree angle here, we know we're going to have a positive 1/2 here. If I go in quadrant 2 with a reference angle 30 degrees here, I'm also going to have a positive 1/2. If I go in quadrant 3 or 4, it'll be below the x-axis, and so then the height I'll have to put a negative 1/2, and it wouldn't work out. So we know we can't work in quadrant 3 or 4 for this, and we have two different locations, one in quadrant 1 and one in quadrant 2 that we're after. So if we could find out what angles we're pointed at, that's the answer to our question, right? Because we're trying to find theta, and theta is this location here, which is 30 degrees, because this is 0 and we've gone 30 degrees from 0. And this location here, which is, well, if half circle's 180, and we go backwards 30 degrees from 180, we're going to go to 150. And so we'll write our answer, theta is 30 degrees and 150 degrees. And that's kind of the process you go through to solve for an angle. Okay. So question on that first one. Let's do another one then. So number 2. Again, we're going to find theta for theta between 0 and 2 pi. Now notice I wrote 2 pi instead of 360 here. By making that adjustment, I'm telling you what form I want your answer to be in, because angles can be in degrees or radians. And so if I'm saying between 0 and 2 pi, I'm telling you, hey, give me your answer in radians. Okay. And so now we're going to just let the cosine of theta be negative root 2 over 2. And so we go through that process again. Our first question is, hey, what's our reference angle? If we have one. What's theta prime? And so I'm going to work with a triangle, hypotenuse of 1, and cosine is the, it's not across from theta, it's the adjacent side. So, and I'm just going to work with positive. I'm not going to worry about the negative. I'm just saying, hey, do I recognize this triangle enough to know, is this a 45, a 30, or 60 degree angle? That's all I'm after. And hopefully you realize, okay, theta prime is going to be 45 degrees. All right. So then we're saying, now which quadrant should we put this in? And here's where the negative matters. Okay, cosine theta is equal to negative root 2 over 2. So in which quadrant will cosine be negative? Okay. So if we draw this triangle in quadrant 2, put a 45 degree angle there, and look at the cosine is down here. This is going to be negative root 2 over 2, so it works out. And it will also work out if we put it in quadrant 3. And getting a little too busy here. I'm going to erase that negative 2 over 2, put a 45 there. Okay. So we're looking for these two locations. Now, what's different about this one is I told you I want the answer to be in radians, not degrees. And so you can get the two answers in degrees and change them both to radians. That's fine, but it's a little more work than what I'm going to do. What I like to do is I take my reference angle and change that to radians. And eventually you start memorizing it because it's pretty easy. But until you do, how do you change degrees to radians? Pi by pi over 180. So we get 45 pi over 180. And you reduce that to pi over 4. And so you'll see this enough, then over time you'll just know, okay, 45 is pi over 4, 30 is pi over 6, 60 is pi over 3, okay, 90 is pi over 2, and so on. But until you get to that point, just work on converting, okay? So I know I'm going pi over 4, and then here I'm gonna work with radians. So here's 0, and this is pi. But because I'm working with pi over 4, I'm going to change it to 4 pi over 4. And this is a great location because it's right in between the two pieces I want. And to get to those two locations, I need to go back 45 degrees or back pi over 4 and forwards pi over 4. So 4 pi over 4 minus pi over 4 would give me what? 3 pi over 4. So that's one answer. And then if I go forward from 4 pi over 4, if I add a 4 pi over, just a pi over 4, we're going to get 5 pi over 4. And now I have my two different angles in radians, and that's my answer. So I write theta is 3 pi over 4 and 5 pi over 4. All right, example 3. Find theta for theta between 0 and 360 degrees. So now I'm allowing you to give your answer in degrees. Tangent of theta is let's go negative root 3 over 3. So sine and cosine are quicker at first for you to find the reference angle. Tangent is a little tougher to come up with it directly because tangent's not part of the triangle. It's a ratio of the sides of a triangle, right? And so because of that, tangent's a little tougher to come up with. But when you're looking for your reference angle with tangent, there's only three possibilities, right? 45 as your reference angle, 30 as your reference angle, or 60 as your reference angle. And until you have done it enough times where you just know, oh, I know which one's root 3 over 3, until you're there, you're just gonna try them out. And so maybe you think, I think that's 45 degrees. Whatever you think it is, go after that first, but check it out, try it out. So I know 45 is root 2 over 2 here, root 2 over 2 here, and so I'll try it. Tangent of 45. That's root 2 over 2 over root 2 over 2. Those are the same, and I get 1, and that's not right. So, okay, we tried it. Didn't work out. It's going to be one of these, though, right? So then I take another best guess. I'll try 30. 30 is across from 1/2, or so 1/2 is across from 30, and root 3 over 2 is here. So tangent 30 degrees. 1/2 over root 3 over 2, reduce that to 1 over root 3, and simplify that. I need to multiply top and bottom by root 3. I get root 3 over 3, and that's what I'm working with. So therefore, I know 30 is my reference angle, right? So with tangent, it's a little more trial and error to find that reference angle until you're comfortable. Eventually it won't be. You'll see it so many times and you'll know. But until you're there, you're going to use trial and error. So then tangent's negative, and you got to locate what quadrant should I put this reference angle to get a negative tangent. Now remember, tangent is a fraction. of sine and cosine. And so even when we're determining like where is this going to be, it's it's y over x. How do you? I want a negative tangent. How do you make a fraction of two numbers negative? What has to be true here? One has to be only one's negative, and the other one has to be positive. And so as you're considering which quadrant, you're trying to think which quadrant would give me a positive and a negative. And there's two different quadrants that would do that. So 2 would work. So if I put 30 degrees here, right, we end up with a negative root 3 over 2 and a positive 1/2. So that would result in a negative. And 4 is the other one. If I put 30 degrees here, I get a positive root 3 over 2 and a negative 1/2. So those are the two quadrants that would give you that negative tangent. And so lastly, we just got to figure out where we're pointed. We're able to use degrees. So if this is 0, this is 180. This is 360 degrees. What's the quadrant 2 angle? 150. Go back 30. We're at 150. And how about quadrant 4? What is it? 330. Because we're going back 30 degrees from 360. You don't want to go back from 0 because that will give you a negative answer. And we have to stay between 0 and 360. So our final answer is 150 degrees and 330 degrees. Let me give you one more example in the notes. Then we're going to take a look at the homework, okay? So let's say find theta for theta between 0 and 2 pi. I want your answer in radians. And I'm going to say the secant of theta is 0. It starts the same way. But if you're in one of the reciprocal functions, especially secant or cosecant, get out of it as quickly as possible, right? So secant is reciprocal with cosine. And what's the reciprocal of 0? Undefined, huh? So I messed up to start with. Let me fix this. Try secant is undefined because I want 0 for cosine. Okay. So secant is undefined, which means that we divide it by 0. Like if you think of a fraction, that'd be like 1 over 0. And so if we want the cosine, we're going to flip that fraction over, and you'll have 0 over 1, which would be 0. And that's what I was intending here, okay? So cosine of theta is 0. And so then we're, okay, reference angle. And we're looking for that. We draw our right triangle, and we're like, okay, this is 1. Cosine side length of 0? Not making sense, right? So sometimes this reference angle idea won't work out. And if it doesn't work out, that means you're not in a quadrant. You're on either the x-axis or the y-axis. And so then you rely on, okay, cosine is x. So this is saying my x-coordinate is at 0. Where is that on your xy axis? It's on the y-axis, right? Any point on the y-axis has a x value of 0. And if it's on the x or y-axis too, we're working with that unit circle. And so where would I be? Where should I go? Top? Okay, so top, what's the coordinate of that point? 0, 1. And x is the cosine, and so that worked. Is there any other location? How about here? This is 0, -1. And the x value is 0 again. So again, I have two locations that would make that work. They're both on the y-axis. I need to give my answer in radians. So how do I do that? This is 0. Half a circle is pi. What's going to be right in between 0 and pi? Half a pi. Pi over 2. What's going to be between pi and 2 pi? So if it helps, because this is over 2, make this over 2, and it might make more sense. So this is 1 pi over 2, 2 pi over 2, 3 pi over 2. And so our answer is theta equals pi over 2 and 3 pi over 2. So number 5 on the homework, let me copy it down. We got -4 plus 1/5 tangent theta equals -20 minus root 3 all over 5. Okay, so at first glance, this doesn't look anything like what we were doing before. I mean, it looks a lot more complicated, but it's really not. All that's happening here is we got one more additional step. We got to get tangent by itself. Once it's by itself, then it's like what are the 4 examples in the notes. And how do we get it by itself? Basic algebra, right? Think of tangent theta as a variable. It's your x, and you want to solve for x. What would be your first step? I'd want to get rid of the fractions, right? You got fractions. They all have the denominator of 5. And so I'm going to multiply each piece by 5, by that denominator, to get rid of that. So multiply the -4 times 5. Multiply this piece right here by 5 to get rid of the 1/5. And multiply this whole thing by 5 to get rid of the 5. And so these will cancel or reduce. This will reduce as well. And so now we have -20, because 5 times -4 is -20, plus the tangent of theta equals -20 minus root 3. Then add 20 to both sides. And now we have tangent of theta equals -root 3. And that's where your notes began, right? So these problems will have a little bit of algebra at first to isolate that trig function. But once you get to that isolated trig function, then follow what I gave you in the notes. Ask, well, what's the reference angle? And what quadrant are we going to be in? And am I going to give the answer in radians or in degrees? And give that. Why don't you try it? I will work it out, but I want to give you some trial and error first, okay? So you just guess and check and pick your best guess. Any guesses? All right, 60. Let's try that one out. So across from 60, we know is root 3 over 2, and this would be 1/2. And so if we're checking the tangent of 60 degrees out, let's just see if that works. We get root sine over cosine, which is root 3 over 2 over 1/2. You reduce that, you end up with root 3, and that's what we want. We want it negative, but we want the root 3, okay? So we know our reference angle, theta prime, is 60 degrees. And that's what we're going to put in our quadrants. So then the next thing we're after is what quadrants? And our tangent is negative. And we had one like that on the notes. And we found that tangent's negative in which quadrants? 60 degrees in 2. 60 degrees in 4. And then once you're there, then you just got to find out, well, where am I pointed? We're able to use degrees here. This is 180 degrees. So if I go back 60, I'm at 180 minus 60, which is 120. That's one answer. If I go full circle, I'm at 360, but I need to go back 60 from that, and I'm at 300. And so my final answer is theta equals 120 degrees and 360 degrees. And that's how it works out. Okay. All right, now let's pick one from the bottom half that you think you might want to work through with a teacher. 14. All right, good pick. Yeah. I don't know why I put 360. I just wanted to see if I don't know. Should be 300. Okay. So next one and the last one I want to do with you is number 14. So here we have negative 3 minus 3 times the cosine of theta plus 3 pi over 4 equals negative 5 minus the cosine of theta plus 3 pi over 4. Okay, so it looks a bit intimidating at first, right? There's a lot going on here. Also, the instructions say to put your answer in radians, right? So this is like all the other ones. You want to isolate your cosine in this case. Get it by itself. And the cosine comes with the angle. So this whole piece is one package together. Okay? You cannot separate any of this. It's got to stay together. So what you may want to do, if this looks too intimidating to you, you can substitute in a variable for it. You can say, well, let's let A be the cosine of theta plus 3 pi over 4. And if I do that, then my equation becomes negative 3 minus 3a equals negative 5 minus a. And that might be a little easier for you to think through. Okay, I could solve for a on that, right? Because it's the same thing. If you're comfortable solving with this with the cosine in it, that's fine. But if that looks too intimidating to you, don't lose it. Just substitute it out. We're going to have to bring it back eventually. But you can substitute it out with another letter. Don't use x or y since we use x or y for sine and cosine. But use some other letter, and then get it. So go ahead and solve for a. So in doing this, you may want to add a to both sides. You may want to add 3 to both sides. Zeroes out a couple pieces here, and you end up with negative 2a equals negative 2. Divide by negative 2, you end up with a is 1. Everybody go with that? Now, what are we trying to solve for? Am I trying to solve for a? What am I trying to solve for? What variable? Theta, right? So a is not theta, but it's helping us get there, and a is related to theta. So I need to get rid of a because a served its purpose already. And so now I substitute it back and say, okay, this is cosine of theta plus 3 pi over 4 equals 1. Now, again, you cannot separate anything in that parentheses with the cosine. That pi plus 3 pi over 4 is inside that cosine. You can't like add 3 pi over 4 to both sides. You can't divide by cosine to separate things. It's a function, it's stuck together. But you may be distracted, like, Mr. Marsh, I'm used to just like cosine of theta, not cosine of theta plus something. That may be causing an issue for you. And if it is, well, you could say, well, let's let b equal that piece, theta plus 3 pi over 4. And if I do that, then I get the cosine of some angle b is equal to 1. And if that looks better to you, go with that and find out what b is. You could leave it like this, but I'm just showing you probably the way you want to do it here, okay? So now when I have this, much easier, cosine of what is 1, and then you start doing what we did in the notes, thinking, okay, is there a reference angle? And so I try a triangle, hypotenuse of 1, cosine's right here, so cosine of b would be 1. But things aren't feeling right here, right? How can I have a hypotenuse of 1, which is the longest side of my triangle, and have another side length equal to the same length as that hypotenuse? Not adding up, right? So what could this mean? Maybe no reference triangle. Maybe it's on the x-axis or the y-axis, right? And so then I start to think, okay, if I have that unit circle, and it's got a radius of 1, and x is equal to 1 in that unit circle, where might that happen? Where is x1 on the unit circle? It's only one location, actually, where x is 1, right here. So x is 1 right there. There's no other location where you're going to have that happen. And so now we found the location. Remember, we're working in radians. So how many radians are at that location? 2 radians? 0 radians is there. Also 2 pi. Which one should I use? Your instructions tell you which one to use. What does it say? It says, it looks like a 0 less than theta, less than or equal to theta, less than 2 pi. So can theta equal 2 pi? No, but theta can equal 0. So we're going to go with the 0. And so we found b is 0. Yay. But were we after b? No, we were after theta. But we're almost there. So now b is theta plus 3 pi over 4. And that's equal to 0. So what's theta? Just subtract it from both sides and you get negative 3 pi over 4. And now we found what we wanted. Okay. So this one we use substitution, and the only other one you'd want to use some substitution possibly is maybe 13. All the other ones you wouldn't need to substitute much at all, or you don't need to substitute at all. Okay. Yeah. Oh, good question. So theta has to be between 0 and 2 pi. So yes. So we need to find an angle that's coterminal. Coterminal. So how do we do that? Or we could just add 2 pi, right, to this. If you add 2 pi, it circles around and it'll make it positive, so coterminal. So that would be 8 pi over 4, which would be 5 pi over 4. So yes, good job, Nathan, on the details. I owe you a candy or something. Huh? Okay. So I'm going to give you guys some time to work on the homework now.